If you run an AI business, or you build these AI solutions, or you're curious about them at all, or if you are a business owner who is interested in adopting AI into your business, you need to stop and watch what I'm going to say. I had a pretty big breakthrough regarding the application of AI in business and how you can make it reliably make decisions on your business's behalf. So if you don't know me, my name is Aidan and I am the founder of Opulence AI. We specifically focus on bringing AI solutions for construction companies, but this video is going to underlie some fundamentals about architecting these systems that will help you build them and confidently guarantee to your client or for yourself that these AI systems can actually take a big portion of the burden with decision making off of your shoulders. Okay, so what am I talking about? To begin, I want to start with where this breakthrough came from. And just to give you a little heads up or a view into my world of what I've been building a system that takes a contractor speaking to a voice agent, and based on that contractor's conversation with the voice agent, turns it into a fully 180 plus line item schedule for their new home build project. And that's been built now because of this breakthrough. The main problem that I was trying to tackle with this system was exactly this. How do you take a contractor's voice input, the conversation that they had between the AI voice agent and themselves, and how do you turn that into accurately adjusted task durations? What is a task duration? I'll give you a quick brief. In a construction schedule, you have line item tasks. Think pour concrete. You have some day that you schedule it to start, some day you want it to finish, but there's always a column in these schedules that is duration. So the problem was, how do we derive duration of these tasks from the voice inputs that the contractor set? The previous solution that I tried to build with this system was, hey, I need to take this, let's just call this I need to take this contractor voice input data and feed it into an AI agent, right? We're going to feed it into an AI agent, and then the AI agent is going to take this and then also look at the scheduled template, and then it's going to equally adjust and it's going to actually create the durations themselves. Now there were a couple of issues with this approach, mainly two. The first issue was latency, how long it took for this agent to do it. Now, if I really wanted to get this AI agent to look at the contractor input data and then create the duration for it, that's at least 150 different LLM calls, each taking around 2 seconds, on the high end, maybe 5 seconds. It just didn't make sense. The second big issue with it is the fact that these LLMs are probabilistic. I tried to solve this by good prompting. I said, for the pre-construction phases of the schedule, you're going to want to look at these examples as like good durations for all of the tasks that are in this phase of the schedule. And I said, okay, yeah, look, now that I gave it an example, maybe it's actually going to have a better output, a more reliable and consistent output. But the reality is they don't have consistent outputs. They're actually built to not have consistent outputs. They always are going to vary within some type of probabilistic range. So that was the other big issue. So how did I actually re-architect this system to solve for that? So the AI agent was still there, but instead what happened was I created an equation. So I had an AI agent output variables that were plugged into an equation. This is not the right equation. This is just to symbolize what an equation was. Those were plugged into this equation, and because it's code and it's math, that duration calculation could be then instantly plugged into every single one of the 150 tasks at once, correctly adjusting and figuring out the durations. Now, we need to back up a bit. First, let's start with a simpler example to kind of show the principles of what I'm talking about. Okay, we're gonna play make-believe, we're gonna play pretend. It's gonna be a lot of fun, I promise. Or I don't promise things. You are a contractor, okay? It is your job as a contractor to decide which of these 3 electrical subcontractors are going to do my job. Which 3 of these electrical companies are going to help me work and build this residential project. So your choice in this example as a contractor is simple. Out of 3 different electrical subcontractors, which one is the best one to choose for the job? All right, so let's just say the 3 different types of subcontractors are subcontractor A, B, and C. All right? Simple. Now, how are we actually going to make this decision? Well, all decisions have variables. These variables are what you think about or reason on, and they help you make your decision. So for the 3 variables that we're going to care about for making the decision, let's just say they're reliability. How often does the subcontractor show up on time? How quickly, or when they say they're going to be somewhere or do something, how often do they actually do it? The next variable we're going to care about is, let's say, how skilled they are. How much experience or skill does that team have? Are they greenhorns or have they been in the game for a while? And then finally, let's just say price. How much do they cost? Now the first step, kind of see what we're making here. The first step is we're going to score each one of these on a scale of 1 to 10. Keep it simple. So 10 being it's a good, 1 being bad. All right, let's say subcontractor A, they're super reliable. Let's give them an 8. Let's say they aren't really that skilled though, so they're just right down the middle. We'll give them a 5 for skill. And then for price, they're getting there. They're a little expensive. It doesn't make sense for how skilled they are. They should not be that expensive. So we'll give them a 4, which means their price doesn't really make sense. Let's go to B. Let's say they are not reliable at all, but they are super heavily skilled. And the price is really bad. They're way too expensive for how unreliable they are. And then finally, subcontractor C. Let's say they're right down the middle. They're half and half, which is still not great reliability. Let's say they're a 6 skill, and then let's say they're a 7 on price. All right, cool. Well, you would think, okay, well, wouldn't we just add all of these up and then whatever the best one is the subcontractor we should go for? No, because the reality of making these types of decisions, or any decision, is different variables should be weighted differently. They should be taken into consideration. They should either be taken more into consideration or less into consideration. So how we actually account for that in this table or an equation is where we add weights. So the weights we're going to add are going to be down here, and they're going to be values between 0 and 1. If the weight is closer to 1, that means that variable has a higher, should be taken into consideration higher when actually creating the final output or grading the final output. It matters more. If it's closer to 0, then that means it doesn't matter as much and shouldn't be taken into consideration as much. So let's just say for our weights we got 0.8, 0.7, and 0.3. So what this means is we really care about reliability and skill, and we don't care as much about price. The next step is creating an equation to accurately score all of the variables and the data that we just plugged in or created. So this equation would be score equals reliability times by RW, the reliability weight, plus skill times by SW, skill weight, and then finally P times by PW equals what we want. Super simple. So let's go ahead and actually calculate all of these. So this first equation would be 8 times by 0.8 plus 5 times by 0.7 plus 4 times by 0.3. That equals, I have it written over here, 11.1. So that scores 11.1. The next one comes out to 10.1. And then the last one is 10.3. All right, so based on our equation, it's obvious we should go with subcontractor A. right? Super simple, nothing too crazy, right? The reason why I just walked through that example is because it is exactly how I'm now approaching building AI agents and how I actually want them to make decisions on the business's behalf. It's not enough to just prompt into the agent and say, here is all the things you should consider. Make sure you think about this, make sure you think about this. Here are the inputs. Output your answer or your decision. That's not reliable enough. The outputs vary too much. So instead, the LLM's job shifts from using its reasoning power to think about what the best option is, just in plain English, to calculating these numbers. The agent's job goes to calculating the input variables or the constants that the equation is actually going to take care of. And the decision itself is going to be decided by the equation. Capiche? What's really cool about this is what we just walked through here is a micro example of exactly what goes on in LLMs. The weights, the different scoring and possibilities, that's what LLMs do, or AI models do, which is millions of times and over many different types of variations. They go and run these equations, they compare the output of that equation to the desired output, and then they'll adjust their weights, they'll adjust their input variables or the constants to the equation in order to actually shift their output closer to the desired output. So essentially what we're doing is we're doing a small little microcosm example for making business decisions. And the LLMs are much better, in my opinion, plugged into creating the variables for it. I'm going to go ahead and show you my duration calculation workflow, and I'm essentially going to illustrate everything that we just walked through here. It's gone now. But I'm going to show you how I actually demonstrated that in a more complex problem, in a more complex equation, to get the desired output that I wanted to.
Okay, now we are at our computer and we have N8N pulled up. Also, if you're not subscribed by right now, you should fix that, because I spend a lot of time building these workflows and making these YouTube videos, and hopefully they bring a lot of value to AI engineers and construction business owners, and maybe just business owners in general. So if you want to stay up to date on a young AI engineer who's actually building solutions that can stand the test of reality, you should subscribe to this channel. All right, big old fancy automation. So what you're looking at is the schedule personalizer. Now, this is essentially a system that takes raw input from a question answer pairs. Here's the question or the example right here. And it's sent over using a voice agent. We're not going to be showing that today. We'll show that later. And it works through the system and then actually generates a fully updated schedule, and it will pop out over here. All right, so it just ran through, and now you're going to see right here, this is the 100, I think this is the RC Spec House schedule, so this one should be 160, 180. This is 182 tasks, all updated with the correct durations based on our equation. Awesome. How does this actually work? Well, to show you how this actually works, first I want to give you a picture of the N8N workflow, and like we'll work through it component through component. So we have first webhook executes, and this is like I showed you before. It is the question answer pairs from the contractor speaking to the voice agent. So here are some questions right here, and then here are the answers. From there, we go into an information extractor node, and I'm looking for 3 specific things that are going to be used in different places. So I need the start date to be turned from, you'll see over here, oh, it just says it right here. We're targeting an early August start date. So this is an answer from the contractor. Well, I just need that to be turned into not text. And then I also need it to take out the crew size and the project square footage, because these are going to be used in the complexity or in the signal calculations. And I'll explain what the signal calculations are in a second. Okay, cool. So after that is pulled out, we're going to go and follow along through the schedule selector path. We'll worry about the signal keys later. So the schedule selector needs to actually just simply output the right schedule to choose. And what do I mean by this? So our third co-founder is a residential construction consultant. He's been working in the industry forever. So he created 3 different, actually maybe it'll be easier to show you on Google Sheets. So he created 3 different template schedules for us to use. And this is the core data that we use that the system actually makes transformations to. This is what it starts out at. And there's an RC spec house, there's a custom home schedule, and then there's a high-end custom home schedule. So what I want to show you here is right here, the typical duration, the short duration, and the long duration. So it essentially gives us a range, a duration range for each task. And a big part of that entire calculation that we were talking about, and the big breakthrough that came, is how does the system know which day to choose between these 2 ranges, right? How does the system know that what to choose for the duration when the range for get bids is between 4 and 20 days? Okay. So I actually use the new data tables feature in Aidan. It's pretty cool. Like you can it's kind of like a I'm blanking. Data frame. It's like using a data frame if you are coding with Python or anything like that, but they kind of, or it's like having a Google Sheet in A to N. It's kind of rough though working with these things. You can't even like copy and paste from them. You have to use if you want to load these tables, these data tables, what I found the best is you have to load them using a Google Sheet, because you can't just copy and paste values in. They're a pretty new feature, so that's why. Okay, anyway, you'll see here I copied the schedule bar for bar into an Aidan data tables. So all that's happening here is, based on the contractor voice input, it's going to select the correct template. It's going to go and use that in the data frame. It's going to pull all of those items. It's going to aggregate them into one. And then right here, what it's going to do is it's going to use the start date here. And it's basically going to update every single start date for the tasks. And it's going to put the start of the schedule at that start date, and then it's going to recalculate every single task start date to essentially respect that new start date. And then it also factors in the holidays. The next stage is what's called procurement. And procurement is where contractors will go and they'll procure different services, items, and materials, which essentially means they're going to put an order or line it up and essentially say, hey, okay, when are you going to be able to deliver my hot water system to me? Or when are you going to be able to deliver my HVAC system or my specialty trim? That's what procurement is. And procurement is a very variable section in a schedule. So this one was important to actually have AI go and fill in some more procurement tasks. So what's happening here is there's already a set base standard procurement tasks. So you'll see over here in our subcontract submittals and procurement section of the schedule, we have a whole procurement list right here. And these are all the different auto-populated most common things to procure. But this agent goes and says, hey, based on the inputs, do I need to add any extra ones that are a little bit more uncommon? And we have a data table here that goes and looks at, based on all of these, I think there's 9 extra procurement tasks, if it makes sense to slot any in. And this agent decided it didn't make sense based on the inputs to slide any more in. And then this code node merges the schedule and the procurement tasks, and then it runs it through this code node, which actually slots them in the right place. And you'll see right here, that is the first input to this, to the equation that we need to run for duration. So now that we understand what's happening at this bottom portion, let's go ahead and understand what's happening up here, because it kind of looks like a mess. So this is where we actually go and calculate the constant variables that we're using for our equation. And I went ahead and made a diagram of what's happening within each agent. So each agent here is tasked with outputting one signal variable, and I'll just show you here. The outputs of these agents look really simple. It's right here. This is all we care about, these 4 different variables: the axis signal, the crew signal, the size signal, and the complexity signal. Take notice that they're all weights between 0 and 1. So first, let's look at the complexity signal. This one listens for anything in the contractor's conversation that makes the project more technically demanding. That could be things like poor soil, tight access, or custom steel framing. Each of the keywords connect to this complexity index table, which has a base weight for how much the factor typically impacts schedule duration. This is the complexity index table that I'm talking about. So the AI actually just multiplies 3 things: the base weights times the severity times the confidence. The severity is calculated based on how many words that are used to describe this complexity, this complex task there are. And then the confidence is another balancing effort to balance out, hey, AI, how confident are you that this complexity is super severe? Then it adds all of those together and runs it through a saturation curve. That's the exponential part of the equation that you see up here. Let me go ahead and highlight that. The curve keeps the signal from going out of control when multiple factors stack up together. It prevents it from overly biasing the entire calculation as a whole. So the final number is the complexity signal you'll see right here, which is basically how much the schedule should expand or contract due to the unique or challenging conditions. So second up, we have the crew signal. So this one looks at the reality of the contractor's field crew, and it compares it against the base crew for what these schedule templates were created for. Because remember, when these different schedules were created, there were assumptions made about the durations. They assumed a certain size of field crew, which was 8. So if a contractor says we'll have 10 guys instead of 8, the AI computes a crew delta, which is just the crew size divided by the baseline minus 1. It then clamps that number so it can't go beyond plus or minus 25%. So more crew speeds things up, and then fewer crew slows it down a bit. But it never goes super extreme. And that's what those clamps do. Those clamps are another way to keep it from going super extreme. So the output of the crew signal becomes a multiplier effect that affects how fast or how slow the schedule runs. All right, next is the access signal. Now, this one focuses on logistics, or how easy or difficult it is to get materials and equipment to the job site. There is access accounted for in complexity, but I thought this was a big enough factor or variable that actually affects duration that it should have been its own signal altogether. This one is pretty similar to the complexity signal, like in the calculation. The AI looks for phrases like cul-de-sac or boom truck or lane closure and matches them against the access index table, and then multiplies the base weight times the severity times the confidence for each factor, finds it, and then sums them up and passes them through an exponential saturation formula. The result is that one number, and essentially accounts for how access constraints to a construction site can compress or extend a construction schedule. And finally, we have the size signal. So this one's purely based on project square footage, because that's a huge factor when it comes to the duration of most tasks. So this one compares the actual project size to the baseline, which again was the assumed project square footage that the scheduled templates were created for. It divides the project size by the baseline and subtracts 1, and then clamps that result between 0 and 10%. So smaller projects don't get faster, they just floor at 0. So a 2,500 square foot home gives a size signal of about 0.14, while a 3,200 square foot home lands around 0.3. And anything beyond that caps out. So we capped it at 0.3. So when you combine all of these signals, the complexity, the crew access, and the size signal, you get a more complete picture of what's actually happening to the job. And these 4 different AI agents use the inputs from the voice to actually assign these different types of weights to them. I wrote a quick note to basically describe how this node works and what it kind of does. So each signal, size, complexity, crew, and access feeds into a weighted duration equation unique to every task group. The system multiplies each signal by its corresponding weight from the task table. This is the task table. So these are 10 different groups that the tasks all are slotted into. And these each have essentially different weights, because this accounts for the fact that the weighted size doesn't affect every single, or the size of the project does not affect every single task the same, just as complexity does not affect every single task the same, just as crew and just as access. So this gives the calculation so much more nuance instead of just being a blanket calculation. From the task table, it adds them together and then applies the result to the task's baseline duration. This instantly adjusts the duration range so larger, more complex, or harder to access tasks stretch appropriately, while simpler, well-staffed tasks compress. So remember, all we're doing here with this equation is we're picking between the short duration and the long duration for a task. And what this does is using an equation, it instantly runs that equation for each task and chooses the best duration for that task within that range. And then we get outputted a whole filtered ready schedule. Also, I can also show you here. So you can see here the used weights. Here are all the weights that it said it used to compute that task. These are from the weighted table. And then you can see the signal adjustment right here. So this one chose 11 days. And you can see here the short duration is 10 and the long is 40 for the electrical permit. And it does that for all 180. So where does this system lead to next? Well, the reason why it spent so long creating this schedule personalization is because we've been developing essentially a voice agent that helps residential contractors run their projects more smoothly. And we started with, hey, what if they can go and generate new schedules on the fly just based on answering a couple of questions? So now my partner at Opulence is essentially building the front end, or we're on our 5th iteration of the build of the front end, which is how it goes. But it's really cool is now that we have this perfect, nice, personalized schedule JSON that's been outputted, all he's going to do is hook into that, and then it's going to plug into his front end, and it's going to be a super coherent experience from a voice interface. Contractor asks questions, it activates this webhook, it runs through this calculation, and then displays them their personalized schedule. And then, of course, they'll be able to edit that schedule using their voice as well. But that's a different workflow and a topic for a different video. Okay, now that that's out of the way, I want to leave you guys with one more thing before I sign off here. And that's going to be a kind of a cool mental model or mental frame to replicate what I did here, but for yourself and some type of other problem that you are trying to solve using an automation. All right, so to think algorithmically, you want to observe, gather unstructured input, what humans say, do, or decide. For example, the contractor voice, the notes, or potentially, job site observations. Then you want to translate that by identifying the signals or variables. Key note here is the variables hiding inside that mess. So the crew size, the site conditions, the access issues. This step is all about finding what are the variables that are hiding within the observable data that actually would affect the decision that needs to be made. And then formalize. You build an equation or a rule system that converts those signals into consistent outputs. So like we did, the complexity, the crew, access size, and the weighted durations. And then next is a quick, the signalization framework. So you want to detect what measurable clues exist, just like up there. The keywords, the metrics, the numeric inputs or conditions. You want to define what range or threshold matters. It can either be 0 to 1, a min or max, or different capped weights. And then you want to assign those weights to each variable. So how important is each factor or variable to the equation overall, and how much should it affect that decision? And then finally, you want to combine them and figure out how do they interact mathematically. And this is ChatGPT. Any AI you do is really good at actually deriving these equations. Just take the time to read what equation it spits out, because it's going to spit out a bunch of random fluff, but you can distill it down and keep questioning it and honing in and say, this part of the equation makes sense. I don't understand what's happening here. Why did you put this in the equation? What is it used for? And then here are just some quick other examples, some stuff I want to go and tackle next using this type of algorithmic thinking system. So lead quality scoring, the signals you could do is the intent, the urgency, their income, and their age. So you could use these as the signals, and then that could output a qualified lead score that is deterministic. It's from an equation. Estimate generation, this one I need to do right away. So a material type, your square footage or your labor rate, and then how do I make that into a bulletproof pricing formula? A maintenance scheduling, so you can use the weather, different based how much your equipment has been used. It could be factored into maintenance scheduling, or the technician load. How busy are they? And that could be an optimized service date. So this is no crazy, huge, groundbreaking thing. Algorithms have been used for a while now to create these types of systems. But I think if you apply more of an algorithmic thinking to certain automations you can guarantee a lot more reliability. So thank you guys for watching. If you are a construction business owner and you are interested in getting some type of AI automation implemented into your business, or you just want to learn more about it, you can go ahead and go to our website, Opulence AI, or you can reach out at the email, Aidan@opulencefunnels.com. If you are curious and you want to learn more about these kind of deep dived AI building topics, I'll link my school community. I'll be posting a lot of deep dive classroom and courses and more videos like these that kind of dive deeper into how to actually build automations like this yourself and sell them to a marketplace. Thank you guys so much for watching, and have a great night.